Hey guys, so over the past couple days you guys have learned about relations and functions. And remember we said a relation is a relationship between two things, and in math it's like an ordered pair, a set of ordered pairs. So like we could have 1, 2, 3, 4, 5, 6. And then we said a function was a relationship in which none of the x's repeated. This is a function because none of my x's repeat, but once I throw in a 5, 7, now I have two of the same x's, and that is no longer a function. So what we can do if we do a graph is a vertical line test. If you have a graph and you have a function, you have a graph that looks like a straight line. So this is your x-axis and this is your y-axis. What the vertical line test is, if you draw any vertical line down your graph, as long as it doesn't hit more than one part of your graph, then it's a function. So what would it look like if I had a graph like this? Well, everywhere I draw a straight line, it's only hitting one x. However, if I had a graph like this, once I draw a line, if you notice it hits the graph twice, that is not a function. And you'll notice that in this case, the x's have been repeated. Okay, so that's what the vertical line test is. So we're going to graph y, and the examples you have in this section aren't going to be lines. You're just going to graph the points. We're going to graph x and y, where y equals x plus 2, and they tell you in this example what x equals. So what you're going to do is, if you know y equals x plus 2, you're going to take the first example of x, which is 1, plug it in for the x, and just rewrite it. Y equals 1 plus 2. 1 plus 2 is clearly 3. So your first ordered pair for this relation is 1, 3. If you plug in a 2, you're going to get 4. So it's going to be 2, 4. If you plug in a 3, you're going to get 5. And if you plug in a 4, 4 plus 2 is 6. So there's your relation, and now you have to graph it. Go over 1 and up 3, put a point. Go over 2, go up 4, put a point. Go over 3, go up 5, put a point. And you can label all these points, 1, 3, 2, 4, 3, 5, and so on. As we move on, you're going to start connecting the dots and make a line. It's going to say graph the line of y equals x plus 2, so you would just connect all the dots. But right now, we're just making points. Okay, the next one is y equals 3, and x is an integer. 1 is less than or equal to x is less than or equal to 5. Okay, keyword, integer. What do we know an integer is? An integer is any number 0 or above that's whole, and then any negative number that's not a fraction. So what do I mean by that? So an integer is -5 or 7 or 10, but it's not 10.5 and it's not -5.5. So it can't be a fraction or a decimal. Okay, so x is an integer. We only have a few choices. 1 is less than or equal to x is less than or equal to 5. So I know 1, 2, 3, 4, and 5 are my integers. That can be x. And then all my y's are going to be 3. So what's that going to look like? 1, 3 is over 1 and up 3 is my x and y axis. 2, 3 is over 2 and up 3. 3, 3. And if this was a line, the line of y equal 3, we would draw a line, but we're not doing that yet. So that's what that one would look like. Over here it says y equals positive and negative x, and x equals 1, 4, and 9. So if y equals positive and negative x, y is going to equal, the square root of 1 is 1. So y equals positive 1. So the square root of positive 1 is 1. Or -1. If you put in 4, square root of 4 is 2, so y equals 2, or y equals -2. 9, the square root of 9 is 3, so y equals 3, or y equals -3. I don't know what they want the difference between those two. Let me just look at my examples for a second. Make a table to find the ordered pairs. For each value of x, you should find 2 values of y. Right. Okay. All right. I see what they're saying. Okay, So you're going to have, if x equals 1, the ordered pair is going to be 1, 1. If x equals 4, the ordered pair is going to be 4, 1, 1 or 1, negative 1. Oops. If you had 4, it's going to be 2 or 4, negative 2. So let's see, and 3 is going to be 9 and 3 or 9 and negative 3. So what is that going to look like? Over 4, up 2, down 2. Is this a function? No, it is not, because you have two x's that are the same. These two x's are the same. So this is a relation, but it's not a function, and you would have to graph all those points. The final one is, it says graph xy, where y equals plus or minus square root of x. Now, they didn't tell you that x is going to be 1, 4, and 9. So this time we can use x as anything. So y equals plus or minus the square root of 16. Or y equals plus or minus the square root of 25, just to make my life easy. But what's going to happen is you can put any number in here, and if you do that, if y equals plus or minus the square root of 16, you're going to get y equals plus 4 or minus 4. Over here, you're going to get y equals plus 5 or minus 5. If you put in 0, you're going to get, if x equals 0, you're going to get y equals 0. What's going to end up happening is you're going to have a graph, and on this one, because it's all, you can put in all real numbers, you are going to actually connect the dots on this one, and you're going to end up having a graph that looks like this, and then that would not be a function. All right, so what you're going to do is you're going to do page 231. They're asking if the relation is a function. You're going to do numbers 1 through 19. And just looking here, you're probably going to get through that pretty quick. I wasn't going to go into y-intercept yet, but maybe I should, and x-intercept. I'm going to tell you what that is, and because you're going to be graphing the linear equations. All right, I'm going to show you that because I think you're going to finish this quickly, and then you're not going to have anything to do, so I'm going to show you the next section, what a y-intercept is and what an x-intercept is. Basically, if you have, so in the next section, you're going to be graphing lines. When it hits the y-axis, whenever the line hits the y-axis, that's called the y-intercept. So when would it hit the y-intercept, the y-axis? Well, x would have to be 0. So when x is 0, y is going to be your y-intercept, okay? Same thing for if y is 0. If y is 0, then x is going to be your x is going to be your x-intercept. Okay? So what does that mean? Okay. I'm going to draw a line here. Let's say I have a point here and a point here. If I drew this line, this point right here is 4, 0, and this point right here is 0, 4. So my x-intercept is going to be at when y equals 0, x is going to be 4. And then up here, if x is 0, it intercepts the y-axis at 4. So my y-intercept is going to be 4. So what does that mean? Let me give you an example. I think I'm going to show you this stuff in class because I feel like there's still too much here to show you right now. So I'm going to show you the rest of this in class, okay? Hopefully I'm far enough in my other classes that I'll be able to do that. All right, so let me know when you're done with the first section.